Hi and welcome to another installment of Math Basics with Mr. Besh. Today's focus, this video details the rules essential to simplifying exponent expressions. Once you've completed this video tutorial, you will have the basic skills needed to simplify more complex expressions. There will also be additional one-and-done videos on simplifying expressions to help you put this all together. So before we begin here with the rules, there are 4 facts that I need to bring to your attention. First, I'm going to be using terms such as base value and exponents in this video. Now, the base value is the larger size term on the left-hand side, and the exponent is going to be the smaller size term in the upper right-hand corner. They are illustrated here in my model as the B standing for the base value and the E as the exponent. Fact number 2, take a look at the model. It shows the base value being B and the exponent being the number 3. What this essentially means is that you are taking the base value B and multiplying it by itself 3 times. So B times B times B. Also look at the bottom and the note, B to the 3rd power is not the same thing as saying 3b or 3 multiplied by b. All right, now this next fact is a very common mistake made by a number of students. Look inside the green box. You will see a 2x with parentheses on the left side and a 2x that does not have parentheses. Parentheses here matter. These two expressions are not the same thing. The one on the left can be further simplified, where the one on the right is totally simplified already. And if you look down below at the note, 2x in the parentheses to the 3rd power is basically stating 2x times 2x times 2x. When simplified, this is 8x to the 3rd power. Now, we are going to explain this 3rd power here as our first rule in our next section. But please make a note here that this parentheses matter, and when a term is in parentheses, it simplifies different than terms that are not in parentheses. And the rules for that are simply because of your orders of operations. You remember your PEMDAS. All right, so the last of my facts is the easiest one. This is fact number 4. It's called the 0 power. Anytime you take a base value and you take it to the 0 power, the answer is always 1. Notice the example in the green box. Also down below as a note, no matter what you have in the parentheses, if you take the term, all of it, to the 0 power, again, it simplifies to 1. The base value can be a negative, the base value can be a positive, the base value can be, a large number, the base value can be a small number. The only time this example will not be true is if the base value is 0. And then as a result, we will get an error. But other than that, this is how this is done. This is called the 0 power. So watch out for this, because when you see these in future complex examples, these are almost like little shortcuts. All right, now we're done with the facts, so let's get into our rules. Now we have 3 basic and fundamental rules, and I have each of these rules broken down into 2 parts, A and B. A will be working with just straight up positive values, and the B examples will have what happens when you have negative values. The student needs to know how to multiply, divide, add, and subtract negative numbers, or the integers here, when doing exponents. So here's our first rule. The first rule is simplifying using multiplication. Now you'll notice 2 boxes here. One is identified as basic math with all numbers, and one is identified with algebra. Okay, these rules work exactly the same way. In the first box, the basic math is showing an example of what happens when you take 2 to the 3rd power and you multiply it by 2 to the 4th power. When you base values are exactly the same, and in this example they are both 2 and 2. What you do when you multiply terms together that have the same base value but have exponents, When simplified, all you're basically doing is adding together the exponential terms. So now the 2 to the 3rd power times the 2 to the 4th power becomes a 2 to the 7th power. Now we're not interested in popping this in on a calculator and seeing exactly what the value is. All we're trying to do here is simplify the expression. Now below, in the algebra box, we're doing the same thing. The base value this time, instead of being 2, is the value x. Okay, so now we're using variables. The rules still work the same way. So when you have an x to the 2 power, and then you're multiplying it by an x to the 6 power, you end up getting x to the 8, because the 2 and the 6 combine together to make 8 through addition. Now remember, the base values need to be exactly the same. If the base values are different, you cannot do this rule. Now here is the second part to the same rule, but this time we are using negative and positive values. Again, the example in the basic math has 2 as a base value. All right, but this time the exponents are -5 and 2. Remember the rules. When you add -5 and +2, that comes out to be -3. So that's why my answer is 2 to the -3 power. Now, in the algebra example, my two exponents are -3 and -4. So now when we combine together two negative values, we add them together and we get x to the -7. All right, so now we get to our second rule, and that is simplifying division. Again, like my last example, you got your two boxes, one being for basic math and one being for algebra. And again, this is the first part with positive values. So now, to show division as we get into pre-algebra and algebra and beyond, we start using fractions. So now if you look at the first fraction, it has 2 to the 7th power in the numerator on top, and it has 2 to the 4th power down in the denominator or the bottom of the fraction. Now, when you see division, what you're basically doing is you're taking the top exponent and you're subtracting it from the bottom exponent. So now 7 minus 4 is the reason why that answer is 2 to the 3 power. Again, like we did in multiplication, notice the base values were both 2. They have to be the same for this rule to work. Vice versa, when we go to the algebra example, the same thing applies. My base values are both the same, x and x. My exponents are 7 and they're 4. So now when we simplify, it comes out to be just simply x to the 3 power. Now, the second part to this, the b, is kind of tricky because you got to pay attention and you got to know the rules for integers. So this is what I was talking about. Take a good look at this. Again, you are going to be subtracting, but I want you to look down below each of these green boxes to see the math that's happening with your integers, because now we're going to get those double negatives, and double negatives turn into positives. So now in the first box, the basic math, you are taking the exponent -7 and you are subtracting from it a -4. And when you take -7 minus a -4, that is like saying -7 plus 4, and that's the reason why the answer comes out to be -3. Now, if you look over at the algebra example, in the numerator, the exponent is a -2. So now when you subtract the denominator's exponent, which is a -3, -2 minus -3 is why we get -5 in our answer. Now we are at our final rule. And the final rule is called a power to a power. And this is an example where what happens when you take a term that already has an exponent to another exponent, hence the term power to a power. Again, two boxes, basic math and algebra. So let's look at the first box. The first box, in the parentheses, you have a 2 to the 3rd power. When you take a term that has an exponent to a higher power, as we are doing here, we are taking the 2 to the 3rd power to the 4th power. What you do in the power to power rule is you multiply the exponents. So now 2 to the 3rd power to the 4th power simplifies to being 2 to the 12th power because 3 times 4. Down in the algebra box, the same thing. You have an x to the 2nd power in the parentheses, a 3 exponent outside the parentheses. So now what you'd be doing is taking 2 times 3, which gives us 6. Okay, so now we're on to the example with the negatives, and notice here we need to know our rules. The first example has 2 to the negative 3 power, and then outside that parentheses is another 3 power. So negative 3 times positive 3 gives us a negative 9. This example, you will notice a negative exponent, and in another video, we'll be talking about exactly what that means. Down at the bottom here in the algebra example, you have an x to the negative 4 taken to a negative 2 power, and when you multiply a negative times a negative, you get a positive. So that's why that answer comes out to be x to the 8th power. Okay, this little video right here was basic exponent rules. I hope you found this both helpful and informative. And also look out for those one and done examples of the more complex stuff.